Hello, this is Mr. Mac, and this video is going to deal with inverse functions. Okay, so let me just start out by writing inverse functions. You might say that inverses put the fun back in functions. No, never mind. Anyway, let's first of all, let's make an informal definition of an inverse function. And what we'll do is we'll say two functions, f and g, are inverses when the ordered pair A, B in F is only true if the ordered pair B, A is in G. Let me see if I can make this a little bit clearer. Anytime you have an ordered pair, xy or AB, in the function f, if G is its inverse, then the ordered pair BA has to be in G. And any ordered pair that's in G, like BA, the ordered pair where x and y are reversed would have to be in F. It's an if and only if thing. This symbol right here means if and only if, or in other words, it goes both ways. So basically, inverse functions take the ordered pairs in a function and exchange the x and y members. Okay. Now, intuitively, what we're saying is that one function is the inverse of another if it undoes what the other one does. In other words, function f will match a with some value b, and so if you give the value b to function g, its inverse, then it will match it back with a. So you get back to where you started. Now, the next thing we'd like to talk about is how do you find the inverse of, before I go on, let me just stop here and tell you, mathematicians have a very, very bad habit. And the habit is to look at you and say, here is a function f. Does f have an inverse? Well, now that's really simple, silly, because all you have to do is take the ordered pairs in f and swap the x's and y's, and you'll get a set of ordered pairs that are the inverse of f. Now, sometimes the inverse of f may not be a function, and that's kind of an important distinction. We'll talk about that in this concept video also. So when mathematicians say, does f have an inverse? What they're really asking is the inverse of f a function? Now, it's going to turn out that we're going to have a test that we can make when we have a graph of a function to see if its inverse will be a function. And now I'm going to try not to use the green question, does f have an inverse, to you, but instead use the question, is the inverse of f a function? But you do need to understand the green question because many other mathematicians will do it that way, and they'll expect you to understand. And I may slip up from time to time and use that question also. And if I do, I'm going to expect you to understand because I told you here in the video that that's what that question means. So please learn that. Now, the next thing that we need to talk about is How do you find the inverse of a function? Well, now there are a couple of things that you can do depending upon the situation. Let's say, for example, you have a function f, and remember, functions are simply sets of ordered pairs. Let's say you have 2, 7, 3, 9, 4, 100, and 5, -2. And I say, find the inverse of f. Well, the inverse of f would be the set of ordered pairs 7, 2, 9, 3, 100, 4, and -2, 5. Now, if you're having any difficulty figuring out how I got those, pause the video and look at these two sets of ordered pairs and see if you can figure out how I got that second set from the first set. You paused? Are you back? Did you figure it out? What I did was I took each ordered pair and exchanged the x member with the y member. See now, I don't want to belabor this point, but I'm going to anyway. See, if 2 was the input, in other words, if I gave f 2, it would give me 7. See, because when the input is 2, the output is 7. If I gave f 3, it would give me 9, etc., etc., etc. Now, if, oh, by the way, we don't have a name for the inverse. Now, what we ordinarily do is we ordinarily use a symbol that looks like this, f to the -1. And we don't read it that way. In other words, f to the -1 is what we write. In other words, -1 looks like an exponent of an f, but we read it f inverse. So if your variable actually names a function and you put an exponent of -1 on it, you read it as f inverse, and that means the inverse of the function, not just 1 over f, which is what f to the -1 ordinarily would mean. So f inverse of 7, see, we would want the inverse to undo what the function did. The function did this. When I gave it 2, it gave me 7. So the inverse function, when I give it 7, it's got to give me 2. In other words, the ordered pair 7, 2. F inverse of 9 would be 3. F inverse of 100 would be 4. And F inverse of -2 would be 5. So one way to find the inverse of a function is to just swap the x's and y's in the ordered pairs. So if you have the function defined as a list of ordered pairs, then you can just swap the x and y values and you have the inverse of the function. Now, I'm sure those of you that are thinking are asking yourself, but what if I don't have a set of ordered pairs, but instead, let's say I have some kind of an equation? Well, I'm glad you asked that. Let's take a look at something like that. Let's say you have f of x is equal to 2x minus 7. Now, what we'd like to do is we would like to find the inverse of f. Okay, and there are 4 steps. There are 4 steps that you follow. Step 1, now some of these may already have been done for you, but the first step is to replace f of x with y, because y and f of x are the same. So in this case, we would write y equals 2x minus 7. That's step 1. Now, step 2, exchange x and y. In other words, wherever you see x, you write y. Wherever you see y, you write x. So that would be x equals 2y minus 7. Step 2, done. Now, step 3, solve for y. Now, you have to do some algebra here. So what I'm going to do is I'm going to solve for y. I'll add 7 to both sides. X plus 7 equals 2y. I'll multiply both sides by 1/2 to get rid of the 2 in front of the y. So I get 1/2 x plus 7 halves equals y. And so I've solved for y now. And then step 4, the final step, is replace this y with f inverse of x. Now, of course, if it was g of x, then you would replace it with g inverse of x or whatever. But, you know, in other words, we write f inverse of x is equal to 1/2 x plus 7 halves. And there's the inverse of the function. Now, as you can hear in the background, my class has come in. So what I'm going to try to do is I'm going to try to pause this video. And I'm back. Now, these 4 steps right here are the steps that you take to find the inverse of a function when you're given a rule for the function. Now, let's take a look at what happens to the graph of a function, or what the relationship is between a function and its inverse if we're talking graphs. Now, first of all, let's do this. We're responding slowly here. Come on, let's go. Hello, wake up. I'm not quite sure what's going on. The smartboard is not responding. Oh, we've got some problem going on here. Sorry about this. I'm not quite sure what's going on here. Here we are back at this page, and okay, now clone page. There we go. That's what I wanted. Now, let's take the function f and the function f inverse and graph them on this. Graph them on the same axis. We don't need that. Don't need that. And we'll just go ahead and get rid of this too. There we go. All right. So f of x is, oh, what happened there? F of x is, we seem to be not aligned here. I'm going to pause again. I'm back. So we have f of x is equal to 2x minus 7, and f inverse of x is equal to 1/2 x plus 7 halves. So if we were to take a graph, somewhere in here there's graph paper. Now, oops, whoa. Sorry about all this fiddling. Okay, let's take f of x is equal to 2x minus 7, and we're going to graph that. Now, we know that f of x equals 2x minus 7 goes through negative 7 on the x-axis, or on the y-axis, and it's got a slope of 2. So there'd be another point here, and here, and here, and here, and here, and here. So the graph would be this line. Now let's just make that one blue. Okay, now f of x is equal to f inverse of x is equal to, what happened here? Something's misbehaving again. There we go. F inverse of x is equal to 1/2 x plus 7/2. So it goes through 7/2, that's 3.5, 3 on the y-axis, and it has a slope of 1/2, so we'd have these points. And that graph would look something like this. And I'm going to make this one red so that you can see that. All right, now the blue equation, blue line, red equation, red line. Okay, now remember what we said before is that if AB was on F, then BA had to be on F inverse. Well, let's take a look. For example, this is the point 4, 1. So is the point 1, 4 on the inverse? Well, yes, it is. How about the point 2, -3? Well, that would be -3, 2, and that one is on there. Let's take a look at points that are actually on the red line, see if we can find whether or not the inverse. Let's see, here is the point 2, 4, -5, 1 is 1, 5, no, let's see. One, 2, 3, 4, 5, 1. 1, 1, 2, 3, 4. Oh, -5. Oops, 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 oops. -5, 1. So how about 1, -5? So if we go 1 to the right, 1, 2, 3, 4, 5. Yes, okay, good. 1, -5. So if a point is on the blue line, then when you swap the x and y, that point is on the red line. And if a point is on the red line, if you swap the x and y, that point is on the blue line. Now, let's take a look at these lines. Or these points that are alike. -1, 5, and 5, -5, 1, and 1, -5, -3, 2, and 2, -3, 1, 4, and 4, 1. Notice all of these lines seem to go, all of these points seem to have lines that connect them that are parallel to one another. Now, let me show you something else here. If we were to actually take the line y is equal to x, and let me just get that one right here. Y is equal to x. That would be a diagonal line going through the origin, going up to the right at 45 degrees. Notice that all of these lines between points are split in half, and the line y is equal to x is perpendicular to them as well. What happens is that the inverse of a function is what we call the graph of the inverse of a function, is its reflection over the line y is equal to x. Every point on the graph, if you go to the line y is equal to x and the same distance on the opposite side, you'll get a point on the graph of the inverse. So it turns out graphically that what you get when you graph a function and its inverse is the inverse is reflected over the line y is equal to x. Now, one way to look at this is to think of the graph as being a graph grid, for example, that is transparent, but you've got the graph grid marks on it. If you could pick it up by that black dotted line, y is equal to x, and spin it 180 degrees without moving the line, just rotate the line, what would happen is the graph itself would kind of rotate around that line, and you'd get the inverse. Why was I going to say that? There was a point I wanted to make about that. Oh, yes. And you see everything that before was vertical would become horizontal when you flip that graph grid. So remember, back when we were talking about functions, if you had a graph, we would use a vertical line to determine whether or not the graph was a function. Well, if the inverse is a function, then the graph of the inverse will not intersect a vertical line more than once. But what has happened is that that vertical line, along with the graph, has actually been flipped through the line y is equal to x, so it's actually a horizontal line before. So if you have the graph of a function, you can use a horizontal line test to test whether or not its inverse is a function. If a horizontal line can be found that intersects the graph more than once, then its inverse will not be a function. Now, we say when a graph's inverse is a function, the function is 1 to 1. So sometimes they will say to you, is such and such 1 to 1? Well, if it is, that means that it passes the horizontal line test, and it means that its inverse is a function. So is a graph 1 to 1, you can use the horizontal line test to say whether it is. Is the inverse of a function a function? Again, you can use the horizontal line to test that. And then, of course, the question that we really shouldn't ask but do, does f have an inverse? You use the horizontal line to test that. All right, now, we've endured a fire drill, we've endured students coming to class, several pauses, some things that weren't quite working right on the smartboard, and we now have, let's recap what we've actually gone through. We started out with defining the inverse of a function. Anytime AB is in the function, then BA is in its inverse. And the intuitive idea is that an inverse function undoes what the function does. Now, it turns out that the graph of an inverse is a reflection of the function's graph over the line y is equal to x. If you have ordered pairs, you can just swap the x and y members of the ordered pairs to get the inverse. And there are 4 steps to algebraically get the inverse. Step 1, replace f of x with y. Step 2, exchange x and y. Step 3, solve for y. Step 4, replace this y with f inverse of x. Now, final thing that we want to take care of here is I want you to know the formal definition, okay? We say that f inverse of x is the inverse of f of x, and vice versa, if and only if f of f inverse of x is equal to f inverse of f of x is equal to x. In other words, what you have to do is take the function and compose it with its inverse in both ways, inside and outside function, and if you get x in both cases, then that's formally showing that the two functions are inverses. And let me show you an example of that with the functions that we actually came up with. Let's see if this will work this time. Let's clone this page. Now, we're going to come over here, and I'm going to get rid of all of this stuff. Well, that didn't get rid of a lot of it, but let's see if I can talk the rest of it into going away also. Very good. Now, here we've got f, and we have f inverse. Now, to show that they are inverses of each other, I'm going to first do f of f inverse of x. Well, now f of f inverse of x is f of 1/2 x plus 7/2. Well, now 1/2 x plus 7/2 is our input, and what we're going to do is we're going to put that into the input for f. And f says when you have an input, multiply it by 2 and then subtract 7. So this will take our input, 1/2 x plus 7/2, multiply it by 2 and subtract 7. And now we'll figure out what we get. 2 times 1/2 x is x. 2 times 7/2 is 7. Minus 7, we get x. Okay, halfway there. Once again, just in case we need this again a little bit later, let's group this and make it smaller, but it'll be there if we need it. Now, we're now going to do f inverse of f of x. Well, f inverse of f of x is f inverse of 2x minus 7. Now, f inverse says when you have an input, multiply it by 1/2 and then add 7/2. So we're going to take our input, 2x minus 7. We're going to multiply it by 1/2 and then we're going to add 7/2. Now you do multiplication before addition, so we'll distribute the 1/2. We get 1/2 times 2x is x, minus 1/2 times 7 is 7/2, and then of course we're adding 7/2, which gives us x. And so therefore, what we've done is we've shown that f of f inverse of x is x, and we've shown that f inverse of f of x is x. And so therefore we've formally shown that the two functions are inverses of each other. There's a lot more stuff in the solution videos. I really invite you to watch those as well, but that takes care of this concept.